Hi scholars, so today I am going to review with you how to do unit conversions using a method called dimensional analysis and using equations to do temperature conversions. So in order to do unit conversions, you have to know what a unit is. Well, units are measurements that we do in science. So if we want to measure distance, we'll use meters. If we want to use volume, if you want to measure volume, we are going to measure it in liters, capital L. If we want to measure time, we'll do it in seconds, which is little s. And if we want to measure temperature, we'll measure it in Celsius, which is temperature. Now, we also use the Fahrenheit scale, which is often what you see on television here in the United States, and we measure in Kelvin, and we'll talk more about what the Kelvin scale means later in the class. So in order to do these conversions, you will often see these prefixes that are in front of each of the units. So you can have, for example, kilometers here, or megameters, or centimeters, right? And they indicate how big or small a unit is, rather than just have a whole bunch of zeros in front or behind a number. So you won't have to use all of these. In fact, you don't have to memorize them. You'll always get the sheet that's in front of you and that's shown on the screen here. But the ones that we're going to be using a lot are mega, all the way down to nano. So all these other ones have interesting names, but they don't show up very often. So from nano to mega is the scale that you will need to know for this class. And again, these prefixes will always be given to you on a quiz or a test. So let's do a problem that you may be more familiar with, and we'll show you how to do this dimensional analysis method. Okay? So if I have $3.47, how many cents is that? Now I know in your head you could probably do that because you say, oh, there's 100 cents in a dollar. Well, let's show you how to do this in the dimensional analysis method, and I think it'll be very clear how you will do it, how you will use this method to do problems that are less intuitive. So this number over here, $3.45, that's my given. So we always put the given on the left side of a problem, which makes sense because we write left to right. We want to put an equal sign and put cents on the right side. And now we need to figure out how can I get from my given that's on the left side to my answer units, which is on the right side. So the way you do that is put a multiply sign and a fraction. And this is going to be called my conversion factor. I'm going to convert from dollars to cents. Now the key is I want to get rid of my dollars because that's in my given, and I want to get cents, which is in my answer. So I put dollars on the bottom because if a unit is on the top of the fraction and the bottom of the fraction, they'll cancel out. And cents goes on top because cents matches the units in my answer. So now I need to know what is the conversion factor from dollars to cents. Well, we all know that $1 is equal to 100 cents. And notice, because they're equal, I can put them on top of each other, and when you put two things that are equal to each other on top of each other in a fraction, it equals to 1. So basically I'm always multiplying by 1. Well, what fractions can I write from $100 equals 100 cents equals $1? Well, I can write 100 cents on the top and $1 on the bottom, or I can write $1 on top and 100 cents on the bottom. Notice these are the same, they're just flipped. So they're reciprocals of each other. So I look here and I say, look, oh, there's dollars on the bottom, so I got to pick this choice here that's on the left as the fraction I'm going to use as the conversion factor I'm going to use in this problem. So I'm going to write 100 next to cents because that's here. That's the number next to the cents. And the number next to the dollar is 1. And now I do the math. $3.47 times 100 cents divided by the dollar. And notice what happens here is that the dollar cancels the dollar, and now we're left with the unit cents that gets to my answer. And since this number 100 is on top of the fraction, we're going to multiply it. So it's 347 cents. Now that, I hope for you, makes a lot of sense. And that's just not a joke. So in this next example that I'm going to do, which is not going to use any calculation that we do in class, I'm going to pick an example which is a little bit strange. So if I were to say that 5 hugs equals 1 kiss, and I had to figure out, well, how many hugs is 325 kisses? Okay, well, we put our given on the left side, 325 kisses, and I want to know how many hugs, so I'm going to put that on my answer, hugs, and I have my conversion factor in the middle. Well, I want to cancel the kisses that are in my answer, and I want to put hugs on the top because that matches my answer. And now I have to figure out what is the conversion factor. Well, notice that the number 5 is next to hugs, so I need to put 5 there. And the number 1 is next to the word kiss, so I'm going to put a 1 there. So it's 325 times 5 divided by 1. And notice that the kisses cancel, so I'm left with hugs in my answer. So if we multiply 325 times 5, we get 1,625 hugs. That's a lot of hugs. So now that we've done that example and you feel loved, we're going to do a problem that will be exactly like the ones that you're going to be asked to do in this class. So our first sample problem is going to be a one-step conversion, and I'll explain to you what two-step conversions look like in a moment. So in this first example, we're going to have 346 grams. How many milligrams is that? A milligram, the prefix milli, is just an indication of that it's a unit smaller than the grams. And in this class, you'll get a lot more experience taking measurements, analyzing data, and using these units. But first, we're going to practice it to make sure that you feel a little bit comfortable with it and good enough to do well on the test and on quizzes. So our given is 346 grams, so we put that on the left side. We put milligrams, which is my answer, on the right side. And I put my conversion factor in the middle. So remember, the given goes on the left, the answer goes on the right, and the conversion factor always goes in the middle. So now I'm going to see. I need to cancel my gram unit, so I put it on the bottom. I need to get my milligram unit, so I put it on the top. Now I need to figure out, well, what's the relationship between gram and milligram? And that's where that sheet comes in with all the prefixes. If you look up the prefix milli, you'll notice it says 10 to the negative 3. So what that means is that 10 to the negative 3 grams equals 1 milligram. Notice that the number on the sheet always goes to the next to the unit that does not have the prefix next to it. I call this the base unit, the one without the prefix. And it's not the one on the right shown here, it's the one on the left. Again, I call that the base unit, or the one without the prefix. And notice there's a 1 next to the milligram, and the 10 to the negative 3 next to the gram. Now, when you see that this 10 to the negative 3 is on the bottom of the fraction, that means when we divide by it, when you divide by 10 to the negative 3, you move the exponent in the right direction. So we're moving it 3 times to the right, so it's 346,000. Now you could write this in scientific notation, 3.46 times 10 to the 5th milligrams. And then you would circle your answer, and then you would receive full credit. So let's try another one. .000471 microgram. Again, microgram has that little tail on it. It looks like a U. It has a tail on it. How many grams is that? So we put our given on the left side, 0.000471 micrograms. We put our answer on the right side in grams. We put our conversion factor in the middle. We want to be able to cancel the unit that we're given, and that's micrograms. And we want to be able to get the unit that we just ended up with, and that's grams. So then we need to look up on the table what micro means. And when you look up micro, it means 10 to the negative 6. So again, what that means is that 10 to the negative 6 grams equals 1 microgram. Notice that the number 10 to the negative 6 always goes next to the base unit. So you put 10 to the negative 6 next to the base unit and 1 next to the microgram. And this is always true for the prefixes. So if you follow that pattern, you'll never get it wrong. So we're multiplying by 10 to the negative 6 because it's on the top of the fraction. And when you multiply by 10 to the negative 6, you're moving it to the left 6 times. Now, over here in my answer, I could move it 6 times to the left, but then I'm going to have a huge number of zeros. So what I'm requiring is that you write scientific notation when in doubt. But notice that this number has 3 zeros in it that are to the right of the decimal place. I'll allow that. But anything more than 3 zeros, and you must write scientific notation. So let's fix this number on the left and write that as scientific notation first. So what's .000471 as scientific notation? It is 4.71 times 10 to the negative 4. Now I'm going to move this 6 times more to the left. So that's 4.71, and all I have to do is add the exponents. So that's negative 10. And I circle it, and there's my answer. So in the next problem, I'm going to do a 2-step conversion. Now I want to go back and show you what the 1-step conversions look like. Notice that one of them always had the base unit in the question or the answer portion of the problem. Notice in the previous problem, there was always the base unit in the given or the answer of the problem. So, in a 2-step problem, both parts of the question, both the given and the answer, will have a prefix. So, let me write a problem down. 2.17 times 10 to the 6th micrograms. We want to know how many milligrams that is. So notice they both have a prefix. So we know it's a two-step conversion problem. So we write our given on the left side, 2.17 times 10 to the 6th micrograms. We write our answer on the right in milligrams, and we know it's a two-step problem. So I write two conversion factors. Now notice, micrograms is in my given, so I want to cancel it out, so I put that on the bottom. I notice that milligrams is in my answer, so I want to write that on the top of my second fraction. But I need to know what to convert it to. Well, if you look at the two previous problems, we always converted to the base unit. So we put the base unit on the top of the bottom. And notice that those two will cancel out eventually. You notice the given will cancel out. So I notice that I'll always get my answer in milligrams when I set it up this way. If you set it up perfectly, you're going to get the right answer every single time. I promise. So now we need to look up what micro means. And micro means 10 to the negative 6th according to your SI prefixes. So you put 10 to the negative 6th next to the base unit. Notice that milli is 10 to the negative 3 on the sheet. So you write that next to the base unit. You're going to move the decimal place 6 times to the left because you're multiplying by 10 to the negative 6. And you move it 3 times to the right because this is on the bottom of the fraction. So remember, 6 times to the left, 3 times to the right, which means overall we're going to move it 3 times to the left overall. So if the exponent is 10 to the 6th, you're going to subtract 3 from the exponent to get your answer, which is 2.17 times 10 to the 3rd milligrams, which is your answer, and you circle it, and there you go. And you can write ones next to the ones that have the prefix, the units that have the prefix, if you choose, or you can leave it blank. Okay, so let's do one more. We will go 0.052 kilometers. It's okay. How many nanometers is it? So we put our given on the left side, 0.052 kilometers. We put our answer on the right side in nanometers. And because we know that they both have prefixes, we're going to have two fractions. We want to cancel our kilometers. We want to get our nanometers. Now remember, we have to figure out what to put in this space. And because in the previous problem, we recognized that we have to convert to the base unit first. Always convert to the base unit when in doubt. So now we have our setup, which is perfect. Notice that the kilometers will cancel the kilometers, and the meters will cancel the meters, and the nanometers matches my answer. So now I look up what kilo means, and kilo means 10 to the 3rd, so I put that next to the one that does not have the prefix. Remember, the base unit is right there. And nano means 10 to the negative 9, so I'm going to put that next to the base unit. And now I'm going to move the decimal point 3 times to the right because I'm adding 3. And I'm going to move it 9 times to the right because I'm subtracting negative 9, right? Remember, dividing by an exponent, dividing by a number with an exponent means subtracting the exponent. So subtracting a negative 9 means add 9, so I'm going to move it 3 times to the right, and move it 9 more times to the right, which means overall I'm going to move it 12 times to the right. Well, if this number over here, when I change it into scientific notation, is 5.2 times 10 to the negative 2 kilometers, they're going to move it 12 times to the right. I'm going to add 12, so the answer is 5.2 times 10 to the 10 nanometers, and I would circle my answer. Notice I would never write all the zeros out because that would mean I would have 9 zeros in my number, and that's just too many to figure out how to count. So the next two problems we're going to practice doing are Celsius, Fahrenheit, and Kelvin calculations using these three equations that are on the top of the screen. Okay? So, if we have 25 degrees Celsius, what's the temperature in Fahrenheit? So, we got to figure out which equation to use. The first equation is where you plug in Fahrenheit to get Celsius. The second equation here is to plug in Celsius to get Fahrenheit. And the third equation is used for two purposes. It's to plug in Celsius to get Kelvin, or we can plug in Kelvin and we subtract 273.15 from both sides to get Celsius. So, firstly we have Celsius and we're trying to get Fahrenheit, so we're going to use the second equation. So we plug it in. Fahrenheit equals 9/5 times 25 plus 32. And make sure we put our units in there. So I can do this using a calculator, or I can do this in my head because 5 and 25 cancel to get 5. 9 times 5 is 45 plus 32, and that's going to be 77 degrees Fahrenheit. Similarly, you could do the same thing for a Fahrenheit to Celsius problem, but I'm not going to show that here. You'll be able to practice that on your own. So in this last sample problem, I'm going to write 327 Kelvin, and we're going to ask how many Celsius is that? So I plug it into this equation over here on the right. 327 Kelvin Celsius equals Celsius plus 273.15. I subtract 273.15 from both sides, and this obviously goes to 0. And after using my calculator, I determined that the answer was 53.85 degrees Celsius. And you have to always write the unit on the right side. So, I hope this video was helpful to you, and if you have any questions, please ask.